Hello children, welcome to the science video session. In this science video session, you are going to learn the lesson Sound from Physics of Standard 8. Come, let's enter into the lesson.
Unit 6 Sound Introduction. We hear variety of sounds in our daily life. Thundering of clouds, chirping of birds, mewing of cats, rustling of leaves, music on the radio and television, and noise of vehicles are some of the sounds that all of us are familiar with. Each sound has particular characteristics. Sound enables us to communicate with each other. Animals also communicate with other members of their species with the help of sound. Some sounds like music are pleasing to us and we like to hear them. But some sounds, for example, noise in our surrounding is undesired. In this lesson, we will study about the production and propagation of sound, human voice system, hearing, noise pollution, and the ways to control it. Come, let's enter into the lesson. Production of sound. Sound is produced when an object is set to vibrate. Vibration means a kind of rapid to and fro motion of a particle. This to and fro motion of the particle causes the substance around it to vibrate. Thus, sound spreads to the surroundings. The substance through which sound is transmitted called medium. Sound moves through a medium from the point of generation to the listener. We can understand the production of sound with the help of some activity. First, we are going to see a simple activity. Take the tray of an empty matchbox and stretch a rubber band around it along its length. Then plug the stretched rubber band with your index finger. What do you observe? Do you hear any sound? On plugging the rubber band, it starts vibrating, isn't it? So you can hear a feeble humming sound as long as the rubber band is vibrating. The humming sound stops as soon as the rubber band stops vibrating. This confirms that sound is produced by vibrating particles. You can see this kind of vibrations in stringed musical instruments such as guitar and sitar also. Next, we are going to see another activity to know the production of sound. Take a metal shallow pan, hang it at a convenient place in such a way that it does not touch anything. Now, strike it with a stick. Touch the pan gently with your index finger. Do you feel any vibrations? Again, strike the pan with a stick and hold it tightly with your hands immediately after striking. Do you still hear the sound? This activity shows that vibrating pan produces sound. In this case, vibration can be felt by touching the pan, but in some cases, vibrations are visible. This we can understand by another activity. Take a metal dish, pour some water in it, strike it at its edge with a spoon. Do you hear any sound? Again, strike the dish and touch it. Can you feel the dish vibrating? Look at the surface of water. Do you see any movement on the water surface? Now, hold the dish with your hands. What changes do you observe on the surface of the water? See, we see that a vibrating object produces sound. In some cases, the vibrations are visible to us, but in most cases, their amplitude is so small that we cannot see them. However, we can feel them. This is what happened in the dish. So, the activity shows that sound is produced when an object is set to vibrate. The sound produced by vibration is propagated from one location to another. When it reaches our ear, we hear the sound. Propagation of sound. That means spreading of sound. When you call your friend who is standing at a distance, your friend is able to hear your voice. How your friend is able to hear your voice? He is able to hear because your sound travels from one place to another. As we saw earlier, sound is a form of energy and it needs a medium to travel. This can be understood by a simple activity. Take a bell jar and a mobile phone. Switch on the music in the mobile phone and place it in the jar. Now, pump out the air from the bell jar using a vacuum pump. As more and more air is removed from the jar, the sound from the mobile phone becomes feebler and finally very faint. So, from this, it is clear that sound cannot travel in vacuum and it needs a medium like air. Sound travels in water and solids also. The speed of sound is more in solids than in liquids, and it is very less in gases. Do you know Thomas Alva Edison in 1877 invented the phonograph, a device that played the recorded sound. Next, we are going to see another activity to know the propagation of sound in liquid. Take two stones or spoons and strike them together and listen to the sound produced by them. It is very clear, is it? Now, take the stones or spoon under water and strike them. You will find that the sound produced by the spoons in underwater is feeble and not very clear. Next, the speed of sound is the distance traveled by sound in 1 second. It is denoted by the letter V. It is represented by the expression V is equals to n lambda, where n is the frequency and lambda is the wavelength. More to know. Wavelength is the distance between two consecutive particles which are in the same phase of vibration. It is denoted by the Greek letter lambda. The unit of wavelength is meter. Frequency is the number of vibrations of a particle in the medium in 1 second. It is denoted by n. The unit of frequency is hertz. Let's see some problems related to the speed of sound. Problem 1. A sound has a frequency of 50 Hz and a wavelength of 10 meter. What is the speed of the sound? So the values are given are n and lambda. So what is n? It is frequency. The value is 50 Hz. Then the lambda value is given, that is wavelength. It is 10 meter. So what is the speed of sound? V is equals to n lambda. So 50 into 10, we are getting 500 meter per second. So the speed of the sound V is equals to 500 meter per second. Next, problem 2. A sound has a frequency of 5 Hz and a speed of 25 meter per second. What is the wavelength of the sound? So in this case, we are going to find out the wavelength of the sound. The values are given. N is equals to 5 Hz. That means the frequency of the sound is 5 Hz. Next, the speed of the light is 25 meter per second. So what's the formula to find out the speed of light? Is V is equals to n lambda. So in this case, we are going to know about the wavelength. So the formula will be lambda is equals to V by n. So 25 by 5, we are getting 5 meter. So what is the wavelength of the sound? It is 5 meter. The speed of sound depends on the properties of the medium through which it travels, like temperature, pressure, and humidity. In any medium, as the temperature increases, the speed of sound also increases. For example, the speed of sound in air is 331 meter per second at 0 degrees Celsius and 344 meter per second at 22 degrees Celsius. Let's see the speed of sound in different medium at 25 degrees Celsius. First, we are going to see the substance which is in solid state. First one, aluminium. The speed of sound in aluminium is 6420. Then in steel, it is 5960. Then in iron, it is 5950. Next, we are going to see the substance which is in liquid state. First one, the seawater. The speed of sound in seawater is 1530 and in distilled water it is 1498. Next, we are going to see the substance which is in gaseous state. The first one, hydrogen. The speed of sound in hydrogen is 1284. Then in oxygen it is 316. We saw that sound travels in different medium with different speed. Now let us see how it travels in a medium. When a body vibrates, the particles of the medium in contact with the vibrating body is first displaced from its equilibrium position. It then exerts a force on the adjacent particle. This process continues in the medium till the sound reaches the ear of the person. In order to understand this, let us consider a vibrating tuning fork. When a vibrating tuning fork moves forward, it pushes and compresses the air in front of it, creating a region of high pressure. This region is called a compression, that is C. Look at the figure. Here you can notice the letter C, that is called compression. Next, when it moves backward, it creates a region of low pressure called rarefaction, that is denoted by the letter R. So these compressions and rarefactions produce the sound wave which propagates through the medium. Sound waves. So we are going to see an activity to know about the sound waves. Throw a stone into a pool of still water. It produces waves which spread rapidly over the surface of water and they travel in all directions. Do water particles move away from the point of disturbance? Check it by placing grains of sawdust over the water. They do not move away. Instead, they merely move up and down about their mean position. Similarly, sound travels in the form of a wave. Sound is a form of energy. It is transferred through the air or any other medium in the form of mechanical waves. Mechanical wave is a disturbance which propagates in a medium due to the repeated periodic motion of the particles of the medium from their mean position. The disturbance which is caused by the vibration of the particles is passed over to the next particle. It means that the energy is transferred from one particle to another as a wave motion. Characteristic of wave motion. In wave motion, only the energy is transferred, not the particles. The velocity of the wave motion is different from the velocity of the vibrating particle. For the propagation of a mechanical wave, the medium must possess the properties of inertia, elasticity, uniform density, and minimum friction among the particles. Do you know how do astronauts communicate with each other? The astronauts have devices in their helmets which transfer the sound waves from their voices into radio waves and transmit it to the ground or to the other astronauts in space. This is exactly the same as how radio at your home works. Types of mechanical wave. There are two types of mechanical wave. They are transverse wave and longitudinal wave. First one, transverse wave. In a transverse wave, the particles of the medium vibrate in a direction which is perpendicular to the direction of propagation of the wave. See, in the given picture, you can notice that the direction of energy transport and the particle movement is perpendicular to each other. The example of the transverse waves are the waves in strings, the light waves, etc. Transverse waves are produced only in solids and liquids. Next, longitudinal wave. In a longitudinal wave, the particles of the medium vibrate in a direction which is parallel to the direction of propagation of the wave. This you can understand by the given picture. The direction of energy transport and the particle movement are parallel to each other. The example of these waves are the waves in springs, sound waves in a medium. Longitudinal waves are produced in solids, liquids, and also in gases. Properties of sound. All sounds that we hear are not the same. There are some properties that differentiate one kind of sound from another. So, we are going to know about the properties of sound. The first one, loudness. It is defined as a characteristic of a sound that enables us to distinguish a weak or feeble sound from a loud sound. The loudness of a sound depends on its amplitude. What is amplitude? Is the maximum displacement of a vibrating particle from its mean position. Higher the amplitude, louder will be the sound, and vice versa. When a drum is softly beaten, a weak sound is produced. However, when it is beaten strongly, a loud sound is produced. The unit of loudness of sound is decibel, that is denoted by dB. Next, pitch. The pitch is the characteristic of sound that enables us to distinguish between a flat sound and a shrill sound. Higher the frequency of sound, higher will be the pitch. High pitch adds shrillness to a sound. The sound produced by a whistle, a bell, a flute, and a violin are high pitched sounds. Normally, the voice of a female has a higher pitch than a male. That is why a female's voice is shriller than a male's voice. Some example of low pitched sounds are the roar of a lion and the beating of a drum. Quality or timbre. The quality or timbre is a characteristic of sound that enables us to distinguish between two sounds that have the same pitch and amplitude. For example, in an orchestra, the sounds produced by some musical instruments may have the same pitch and loudness. Yet, you can distinctly identify the sound produced by each instrument. Then, more to know. As you already know that amplitude is the maximum displacement of a vibrating particle from its mean position, it is denoted by the letter A. The unit of amplitude is meter. Audibility and range. According to the frequency, we can classify the sounds into three types. They are audible sound, infrasonic sound, and ultrasonic sound. First one, audible sound. Sound with frequency ranging from 20 Hz to 20,000 Hz is called sonic sound or audible sound. Sound with this frequency range alone can be heard by the human beings. Human ears cannot hear sounds with frequency below 20 Hz or above 20,000 Hz. So this range is called as audible range of sound. Infrasonic sound. A sound with a frequency below 20 Hz is called subsonic or infrasonic sound. Humans cannot hear the sound of this frequency, but some animals like dog, dolphin, etc. can hear. Uses of infrasonic sound. It is employed in the Earth monitoring system. It is also used in the study of the mechanism of human heart. Ultrasonic sound. A sound with a frequency greater than 20,000 Hz is called as ultrasonic sound. Animals such as bats, dogs, dolphins, etc. are able to hear certain ultrasonic sounds as well. Some of the uses of ultrasonic sounds are: it is extensively used in medical applications like sonogram. It is used in the sonar system to detect the depth of the sea and to detect enemy submarines. It is also employed in dishwashers. Another important application of ultrasound is the Galton's whistle. This whistle is inaudible to the human ear, but it can be heard by the dogs. It is used to train the dogs for investigations. Musical instruments. Some sounds are pleasing to the ear and make us happy. The sound that provides a pleasing sensation to the ear is called music. Music is produced by the regular patterns of vibrations. Musical instruments are categorized into four types. They are wind instruments, reed instruments, stringed instruments, percussion instruments. First, we are going to see the wind instruments. In a wind instrument, the sound is produced by the vibration of air in a hollow tube. The frequency is varied by changing the length of the vibrating air column. Trumpet, flute, shennai, and saxophone are some well-known wind instruments. Next, reed instruments. A reed instrument contains a reed. Air which is blown through the instrument causes the reed to vibrate, which is in turn produces the specific sound. Example of reed instruments include harmonium, and mouth organ. Next, stringed instruments. Stringed instruments make use of a string or wire to produce vibrations and hence the specific sound. These instruments also have hollow boxes that amplify the sound that is produced. The frequency of sound is varied by varying the length of the vibrating wire. Violin, guitar, sitar are some of the examples of stringed instruments. A guitar string has a number of frequencies at which it will naturally vibrate. These natural frequencies are known as the harmonics of the guitar string. The natural frequency at which an object vibrates depends upon the tension of the string, linear density of the string, and the length of the string. Percussion instrument. Percussion instruments produce a specific sound when they are struck, scratched, or clashed together. They are the oldest type of musical instrument. There is an amazing variety of percussion instruments all over the world. Percussion instruments like the drum and tabla consist of a leather membrane which is stretched across a hollow box called the resonator. When a membrane is hit, it starts vibrating and produces the sound. Sound produced by humans. In human being, the sound is produced in the voice box called the larynx, which is present in the throat. It is located at the upper end of the windpipe. The larynx has two ligaments called vocal cords stretched across it. The vocal cords have a narrow slit through which air is blown in and out. When a person speaks, the air from the lungs is pushed up through the trachea to the larynx. When this air passes through the slit, the vocal cords begin to vibrate and produces a sound. See, the vocal cord, trachea, and the cartilage are shown in the picture. By varying the thickness of the vocal cords, the length of the air column in the slit can be changed. This produces sounds of different pitches. Males generally have thicker and longer vocal cords that produce a deeper low pitch sound in comparison with females. Mechanism of human ear. Ear is the important organ for all animals to hear a sound. We are able to hear sound through our ears. Human ear picks up and interprets high frequency vibrations of air. Ears of aquatic animals are designed to pick up high frequency vibrations in water. The outer and visible part of the human ear is called pinna. It is curved in shape, isn't it? It is especially designed to gather sound from the environment, which then reaches the eardrum, that is tympanic membrane, through the ear canal. When the sound wave strikes the drum, the ossicles move inward and outward to create the vibrations. These vibrations are then picked up by special types of cells in the inner ear. From the inner ear, the vibrations are sent to the brain in forms of signals. The brain perceives the signals as sound. So, in the given picture, you can see the outer ear, the middle ear, and the inner ear and the eardrum. Noise pollution. Any sound that is unpleasant to the ear is called noise. It is the unwanted, irritating, and louder sound. Noise is produced by the irregular and non periodic vibrations. Noise gives us stress. The disturbance produced in the environment by loud and harsh sounds from various sources is known as noise pollution. Busy roads, airplanes, electrical appliances such as mixer grinder, washing machine, and untuned radio cause noise pollution. Use of loudspeakers and crackers during the festivals also contributes to the noise pollution. The major source of noise pollution is from the industries. Noise pollution is the byproduct of industrialization, urbanization, and modern civilization. Health hazards due to noise pollution. Noise creates some health hazards. Noise may cause irritation, stress, nervousness, and headache. Long term exposure to noise may change the sleeping pattern of a person. Sustained exposure to noise may affect hearing ability. Sometimes it leads to loss of hearing. Sudden exposure to louder noise may cause heart attack and unconsciousness. It causes lack of concentration in one's work. Noise of horns, loudspeakers, etc. cause disturbances leading to lack of concentration. Noise pollution affects a person's peace of mind. It adds to the existing tension of modern living. These tensions result in disease like high blood pressure or short tempered nature. Controlling noise pollution. So, we studied about the harmful effect of noise pollution. It becomes necessary for us to reduce it. Noise pollution can be significantly reduced by adopting these steps. Strict guidelines should be set for the use of loudspeakers on social, religious, and political occasions. All automobiles should have effective silencers. People should be encouraged to refrain from excessive honking while driving. Industrial machines and home appliances should be properly maintained. All communication systems must be operated in low volumes. Residential area should be free from heavy vehicles. Green corridor belts should be set around the industries as per the regulations of the Pollution Control Board. People working in noisy factories should wear earplugs. People should be encouraged to plant trees and use absorbing materials like curtains and cushions in their home. Hearing loss. You may have hearing loss without realizing it. The following are the symptoms of hearing loss. They are earache, a feeling of fullness or fluid in the ear, ringing in your ears. Hearing loss is caused by various reasons. Some of them are aging, ear infections if not treated, certain medicines, genetic disorders, a severe blow to the head, and loud noise.